and this is going to be your camera's location. So let's say you switch between cameras, this is going to work universally regardless of which camera you're using. However, since in this logic we are using this camera's reference, let's say we had another camera, this logic is not going to work. It is going to work with respect to this camera. So instead of this, I can go ahead and replace it, and we can get the actor forward vector again, get actor forward vector, and we can replace this by this, and we can go ahead and delete it, and the rest of the logic remains the same obviously. And now if I were to press play, you'd see that the logic does not work. Okay, we didn't plug it in. So the actor location is going to be the start, of course, not 0. Press play and the logic works exactly the same. One more thing you'll notice is that the line trace is going exactly to the center of our screen, if you were to notice. That's one more thing. The reason it's happening like that is because we are going from the center of our viewpoint and going exactly forward to the view. So that's the reason it's actually going right at the center of the screen. And if you had a crosshair in game, it would land right at the center. So this was raycasting. There are many other options as well, such as hit actor. So you can cast it. So let's say we cast it to pickup, for example. So we can check if we actually hit a pickup. So if we actually did hit a pickup, what we can do, in fact, is we can go ahead and run some logic. Let's say we destroy it. So I'm just showing you guys one more example to make things clear. So if I press play, so that's not a pickup, so nothing happened. But if I hit a pickup, as you can see, we are destroying it. So something like a gun. All this is fine, but we do not have any sort of a user interface. Now, apart from the lighting needs to be rebuilt thing, you can actually delete that by typing in disable all screen messages. So, oops, I didn't type that. So, disable all screen messages. So, you can go ahead and type that and it's going to remove that. So, there's nothing much really. We don't even have a simple health bar. So, we can go ahead and add a couple of components on screen. So in order to create widgets on the screen, if you want user interfaces, the way you do that is using widget blueprints. So let's get to that. Inside your content folder, I want you guys to create a new folder and we can call this one UI. And inside this, we can call this one, for example, HUD to denote heads up display. Now open it up and inside this folder, right click and create a widget blueprint by heading into user interface. Now you could do it through the blueprint class menu as well. Type in widget blueprint. You should find a widget blueprint somewhere over here. So user widget is the one actually. So go ahead and select that. And we can call this one HUD BP underscore HUD. Generally, I also like to add underscore WB to represent widget blueprint. But if we are going to have separate folders for each one, it's not really required. Open it up and you will get a blank canvas and you'll have two tabs over here on the top. You have a designer and a graph as well. So what we'll be using most of the time is the designer, and to add the logic for it, we are going to use the graph. If you guys have used the Qt framework in C++, the functions and stuff work pretty similarly over here, but since this is going to be in blueprint, it's going to be much easier to comprehend. Now the most basic type of widget that you can add is a canvas panel. So add in a canvas panel. Before, this actually used to come by default without you having to actually add it. Now you won't worry about most of the settings actually. The only thing that you'll worry about is custom or filled screen actually. These are the only two which you'll most probably use. Custom is basically used if you have stuff like drop down and you're making like a child widget for something. And I will show you guys examples for that when we go to the higher level part. So for now we'll use fill screen. So this is going to take up the entire screen. Now in order to actually create this, now there is nothing, but we can just create it nonetheless. Generally it's not advisable to create it in the character. Widgets usually would be created in something a little more persistent. such as a player controller. So we have one set up already. So we make sure you set that in the game mode, open it up, and we could do it on begin play. Add in a custom event, and this is where you actually use custom events. So you could use a function, no harm with that, but let's use custom events. This is what you would use them for. So we are going to be calling this one, for example, create HUD, and we can call that, so create HUD. Over here, we can go ahead and type in create widget. We'll get to select it, so BP HUD is what we want to create, and we can promote this to a variable and call this one HUD. Or you could call it HUDref if you really want to be that specific. Now we have a reference to the HUD. However, we still haven't actually created it. We have just internally stored it, but if you want to show it on the screen, type in add to viewport. So now this should be added to your screen. However, there is another thing which you could do actually. There is another option called add to player screen. However, this is not really used that much. So this is usually used for split screen and stuff like that. We'll not get into this. So you'll use add to viewport most of the times. Alright, so now under your HUD, for the health bar, obviously we need a progress bar. So type in progress bar and Unreal has everything built in for us. So let's add it at the bottom left hand side of the screen. That's the reason I chose the canvas panel, so that we can easily just drag stuff in. With other types of widget, it's usually like a layout which you create. So it's going to be harder for you to just move things around. Alright, so let's add the progress bar. And on the right hand side under the details panel, we can rename it. We can call this one health bar. And we can set all sorts of parameters. Maybe we can make this one 350 by 45. And over here you'll see another tab called anchors. Now anchor is basically telling you the position with respect to it. Basically, for example, let's say set it to bottom left. In this case, bottom left is ideal. So this is going to be your 0, 0, and with respect to that, your y and your other values are going to be set. So when I say the anchor is at the bottom left and my position is 88, what I mean is I have placed this progress bar 88 units to the right of this anchor. And y is basically your vertical direction. So minus 120 is 120 units upwards basically. And size X and size Y will remain the same. Alignment is basically telling you what to take as the reference point. So if I make this 0.5, you see it's going to center off. So it's the distance between this and the center now. Same with the Y. So if I type in 0.5, it'll move a little bit down or up actually, because it was over here. So now the point shifted over there, so it moved a bit up. And if you want to center something exactly at the center of the screen, so for example a crosshair, so you would set the anchor to be this, the center one, and over here you'll change the alignment to 0.5 and set the position to 0 and 0. Now this is going to be perfectly centered regardless of your resolution. Now another reason to actually use this, so let me just actually move this back, so 0, 0. Another reason to use anchors is for different resolutions. Let's say you had an 800 by 600 screen. Let's say somebody is playing with that and you had a progress bar over here. Let's say you left it at the default anchor. Let's say you didn't actually modify the anchors. This widget is actually going to go outside the player screen. However, if you change the anchor to the bottom right, now this widget is minus 461 and minus 137 relative to the bottom right corner. So then it will always be inside the screen. So that's another reason to use anchor. So I'll go ahead and undo all of that. So that should be good. Now if I go ahead and create this, so in our player controller, on begin play we are actually creating it. Now if I go ahead and press play, you see we see our progress bar. And since we have our anchor over here, you see it always stays at the same relative position on the screen. The next thing that you obviously want to do is actually bring in the values of health from the character to the actual widget. So it's actually pretty simple to do that. So let's go step by step. There are quite a few ways in which you can do it. So if we would have created the widget on the character, it would have been simple to just pass in the health value to the widget. However, since we have done it in the player controller, there is an extra step, but nothing to be worried about. So now let's create an event in the player controller so that we can actually interact with the widget. So we can call this one update health, for example. So type in custom event and call this one update health. And for the new value, we can go ahead and add in an input, and it's going to be of type float, obviously, and we'll call this one new health. Now over here in the progress bar, we can go ahead and create another event, or we could even directly adjust it here. So we could get the HUD, and over here we could type in, first of all, let's check if our progress bar is a variable. Make sure it's set to is variable, otherwise you won't be able to access it. So if once that is variable, get the health bar. And again, this is where your blueprint menu is going to help you a lot. Now you want to set the percentage. So type in set %. You will go ahead and get this node. Now in case you guys don't know, this % is going to be a value between 0 and 1, and our health is a value between 0 and 100. So let's just divide this by 100. So do that, or you could make your health variable store 0 to 1, that works too. Alright, so you can do that, or you could have a custom event inside your BP HUD, that works too. So let's head back into a character now. And what we can do is we can actually do something. So let's say when we actually pick something up, let's say we reduce our health, for example. So we can head into our interaction. So when we pick it up, let's say we reduce our health by 10 maybe. Now if it is valid, we destroy it and we invalidate the nearby pickup. And let's reduce our health by 10. So create a health variable first of all. Now health is a variable which is dependent on which character you're in, so that's why we are creating it in the character. Make this private over here, make this variable private, and we can go ahead and set the health to be equal to, we can go ahead and set the health to be equal to health minus 10. And we don't want it to actually go below 0, so we can go ahead and clamp the value. So we can call this one clamp. So clamp float, minimum is 0, maximum is 100, obviously. So you can go ahead and set it. Now if our health is 0, so if our health is less than or equal to 0, if you don't clamp it, you can check for less than or equal to, so let's do that actually. So if our health is less than or equal to 0, less than or equal to 0, we can go ahead and just kill our player. So instead of killing it, let's just exit the game instead. So we can execute a console command. So type in execute console command, and this one we'll simply type in exit. It's going to exit the game. Even quit works. Now this is something which you might need multiple times. So what we can do instead of this is we can actually make a set health function, because we want to exit the game even if our health is reduced for some other reason. So here in this case we picked it up, so our health reduced, but we want to be able to reuse this. So right click, collapse this to a function and call this one set health. Now let's say you don't want this to be able to called on the other blueprints. So let's say you want to only be able to call it in this BP character. You can make it a macro instead. And obviously we need the health value. So grab in health and head back into your event graph, pick up. Over here we can go ahead and pass in the health. So this is going to handle everything for us. And let's actually make this a larger value. Let's say 40. So on our third pickup, in theory, we should exit our game. And if it is not less than or equal to 0, we can go ahead and update the progress bar first things first. And remember we had our player controller reference. Now we can go ahead and use that. So regardless of what we do, we want to update the health bar. I mean, we'll exit over here, so we don't need to update it. So we can type in update health. And new health is going to be our health variable. Now, some people might show you how to do this using a binding. So you can actually go into your progress bar and you can type in bind and create a binding. However, this is very inefficient and it is going to run on tick. So actually don't really bother using that. Do it the way I am showing you guys. This is the proper way to do it. However, there is a small chance that it might miss. It might not update, but that's nothing to worry about. It's going to be like 1 in a million maybe. So it honestly doesn't matter. So once that's said, we should be good to go. And make sure by default your health is set to 100. And once just update the progress bar once you set the player controller reference, because we are not actually setting the health by default. In the HUD you could set it. However, what if a player disconnected from a match and is coming back? So you don't want it to be 100 because you'll be creating the widget once again, right? So set it once you get the player controller. So in our initialize function, once we get the player controller reference, we can go ahead and set that. And we'll clear the timer at the last. Order doesn't matter here since this function is already being executed. The order honestly doesn't matter, but we can do it like this. Now if I go ahead and press play, you'd see our health is set to 100. And if I go closer, okay, let me just speed that up a bit. So if I interact with this, nothing happens. But if I go ahead and interact with this, our health reduces. My health reduced. And now we exit the game the third time we do that. So this is basically how you work with widgets. So if you want to update it, you would just use one of the functions which are there in one of these widgets. And what if you wanted text? Obviously, you would just search accordingly. Type in text and you should be able to find text. So let's actually type in the actual health value. So over here, what we can do is we can just give 100 by default, or we could leave it a text block and set it normally. So over here, get back into your player controller, and in your update health function, we can go ahead and grab our text. I don't know if it's set variable. So it is not set to be variable. So we can type this one health text. Now you should be able to access health text from the player controller once you set that to is variable. So grab in our HUD, health text. So get your health text. And over here we can go ahead and set the text to be equal to the health value itself. Now there is a special node which you'll use a lot called format text. So this is very simple actually. Use curly braces and type in health. It will make a pin for you. Whatever you type in curly braces will be a pin. And the first one, let's just put a plus over there because it's usually health is denoted with a plus before. So your text is basically going to be plus along with a health appended with your health. So let me just show that actually. So grab in your new health. You can grab in any sort of pin by the way. Now if I go ahead and press play, you see it says plus 100 because it took plus and the actual health value itself. Now I apologize, I do realize that the screen is a little bit black and white. So now it should be fine. So you have plus and you have your health. Similarly, you could do something like maybe hyphens. So it's just going to append it as is. You can go ahead and mess around with it a little bit. Let's say you wanted another parameter. You could put curly braces once again and type this one maybe something. And over here, you can go ahead and make a literal string or a text. So let's just say hi for example. So it's going to print plus 100 space hi. If I put a hyphen here, it's going to take it as is. So plus 100 hyphen hi. So stuff like that which you can do using this format text node, and it's really handy in my opinion. So now if I go ahead and press play, we have our health bar. Now we could do a little more of designing. So head back into your HUD and you can actually wrap this around with a border. If you right click and type in wrap with, you can wrap it with a border and actually have a border color and stuff. So I can select this and make sure you set your padding to whatever you want. Padding is basically the spacing you give. So if I change the padding in this case, so if I change this to 10, you'd see that you're giving more space on all directions. I'll just set it to something like 5 maybe. And I'll make this one black. So not content color, that's going to be a progress bar color. Instead go to brush color and change that to something dark maybe. And over here as well, let's just change the fill color to green because that's more appropriate for your health widget. So change that to something a bit more greener. Now if I go ahead and press play, you'd be able to see we get the appropriate color and our health bar updates as normal and our text updates as well. So that's basically it. So that's the basics of widget blueprints. We will talk a lot more in depth about this as we move further. But now you guys should have a pretty basic idea on how to create stuff. Now the palette is something which I want you guys to explore. So checkbox is a checkbox and you won't use most of these. Most often you'll use text, slider, button, image, border, and images as it says, it's an image. And one more which you might use if you want something like a username password menu is a text box. So you can grab in a text box and this will allow the user to enter any text inside. Stuff like that. Now I want to cover widgets in a little more detail. So let's actually create another level called main menu and let's actually transition to this level using a widget. So like you'd click the play button in your widget and then you would enter this level. Let's do that now. First we can go ahead and create our map. So head into content, maps, right click, create a new level and we can call this one main menu. Open it up, or rather let's just be a little more descriptive, call this one main menu level. Open it up and this should be blank and that's really none of our concern. Head into UI, create a new folder and we'll call this one main menu. Over here, go to user interface, widget blueprint and go ahead and select user widget. Now we can start making our main menu. So we can call this one BP underscore main menu. Open the widget and we can just have a canvas panel again. Add in a button. We can center it first of all. So make it 0.5 and 0.5 and set the positions to be 0. We can increase the size a little bit. Maybe we could make that something like 350 by 100 maybe 450. Again, size is your personal preference. And we can make the background black. So background color, change that to something darker. Maybe something like a dark gray. We can go in and add in some text and we can call this one play. Now you can change the font as well, by the way. Under font, you can actually import your own custom fonts. We'll not get into that, but it's actually pretty simple to do it. We'll try to get into that in the later part of the course, but I'm not really sure if I will. So maybe change that to regular, increase the font size to 35, let's say. This should be good. Now head into your event graph and let's call this one play button. So select the button and then under the details panel rename that. Now if you select the play button variable, you should get a bunch of events including on clicked, on pressed, on released. All of these are as they stand obviously. Maybe if you have a sound effect or something, you could play it on hovered. Or there's another way actually where you can play a sound effect when you hover your mouse. So over here, if I just type in hover, I should be able to find hovered sound. Let's just play, so maybe let's just play this. I mean, it doesn't make any sense, but anyways. And I think there is a click sound or a press sound, I guess it's called. So we can play press sound. So click on button. And what we can do is on click, we can go ahead and open our map. So we can type in open level and we can do by object reference. So over here, let's just select our level, beginner course level, and that should be good. Now if I go ahead and press play, as you see, nothing happens because we haven't created the widget yet. Now since this is a widget which is the only thing in this level, you could simply go ahead and create the widget here on begin play. So create widget, BP main menu, add to viewport. We don't really need to store it because we are not actually calling any functions. So if I press play, you can see it, and when we hover over it, you see you get the sound effect. However, one thing you would notice is if you actually have your focus on the window, you can't see your mouse cursor. So the way you do that is, first of all, get your player controller. So type in get player controller. This is a static function. So inside any actor, basically, you can get your player controller reference. And from here, there's actually a variable called set show mouse cursor. So show mouse cursor is the variable. Set that to true. And another thing which you can do actually is change the input mode to UI only, so that it only focuses on this widget. There is another option called game and UI only. We'll use that. Set input mode to game and UI only. Grab in the player controller reference. And that should be good. So we can just reroute it. Double click on the pin to reroute it. And now if I go ahead and press play, you see even when I focus it, I can still see my mouse cursor. Now if I press play, you see we transition to the level. Now we obviously spawned at 0, 0, 0, so that's the reason that happened. Now if you want to fix that, you can go ahead and add in a player start where your default player will spawn. So now if I head back into the main menu, play it, if I head in, we will spawn where our player start was. But one thing you'll notice is we still haven't actually got rid of the mouse focusing part, so your mouse isn't behaving like how it should. So what we can do is on begin play, now we are in our main menu level, head into our beginner course level. Generally you do it on your player controller, so BP player controller. And what you can do is you can set input mode game only, and we can get a reference to self, and you can also set show mouse cursor to false. So set show mouse cursor, make that false. Now if I go ahead and press play, okay, I mean that wasn't what I intended. Now head back into your main menu, go ahead and press play. Now you see your mouse is going to behave normally. So that's basically how you deal with it. Now you can do your normal gameplay stuff. So that's how you would actually interact with your actual levels and stuff. You would transition levels and stuff using widget blueprints. So head back into UI, main menu, and if we take a look at our code, it's really simple. And our widget as well, it's really simple. So that's about it. Now let's say we wanted to have more than one option, and let's say we wanted to lay them vertically. So if you want to add multiple rows, you can go ahead and use something known as a vertical box. So if I right click on this, type in wrap with and use a vertical box, you can go ahead and get this. Now the vertical box will automatically use the same anchor as we used for the child, but nonetheless, it's just something which you can change. Change the size Y to something big maybe, and press Ctrl D to duplicate this button. Now over here I can type in exit, let's say, and again on clicked we can change that. So play button 1 is not appropriate, we'll change that to exit button. So exit button, and on clicked we can go ahead and execute console command, and we can type in exit. So that should be good to go, and you'll notice one thing, it's just taking up a fixed amount of space and it's not actually filling it properly. So if you want to do that, you can select both of these and select fill, Now let's say you wanted your play button to occupy more amount of space than exit. So you can increase this uh, what text box which is available to you. So if I hit 2 and the exit button has 1 on this option, basically they are occupying space in the ratio 2:1. That's basically what it means. So you don't want your players to exit obviously, so you'd make the play button bigger. So this is how you do it. Now if I press play, now the same logic is copied over. The reason why the sound is playing even for the exit button is because we copied over the code. So that's why. So all the sound effects as well is copied. So as you can see, press sound and hover sound are actually the same in both of these. Now if I press play, if I press exit, we are going to quit the game. If I press play, we load into this level. So that's pretty cool. So that's about it for this part. Now it's time we start talking about another feature which Blueprint offers, that is Blueprint function libraries. Now let's say you wanted to have some functions which might be used in multiple places but are not relative to a certain object. So in that case you would use a Blueprint function library. So let me actually show you guys an example. So head into Blueprints, and or maybe we could create another folder. Let's call this one function libraries. Open it up, and over here right click, head into Blueprints and select Blueprint function library, and we can call this one my or our Blueprint function library. Now inside here you would notice that we actually have functions, options to write functions. So for example, let's say we have something generic. So for example, let's say we have a vector, and let's say we wanted to normalize it. Now obviously there is a normalize function already, but I'm just taking an example. Now normalizing a vector is a general operation. It's not relative to any object. So we can type in normalize, and for the input obviously we are going to take in a vector. So take in a vector, and we can type this one in maybe. And now once we have the vector, we are going to first of all get the magnitude of this vector. The way you get magnitude of a vector in Blueprint is by typing in vector length. So get vector length. Now this is the magnitude of the vector. So we can divide this vector by the magnitude. So that is going to normalize the vector for us. And once we actually do that, we can go ahead and return it. So this is going to be the return value, and obviously we'll make it a pure function. Now let's just call this one normalize underscore hours, because I think there is another function called normalize, so just so that it's understandable for us. Now head back into any one of your blueprints, let's say our level blueprint, and over here if we just type in normalize, so we already had a normalize function, but I just took the example, underscore hours, you see we actually get our function, and this is not relative to any object, so you can call this pretty much everywhere you wish. So this is basically your Blueprint function library. You just go on creating functions. So once that's all settled, now what if you wanted to use some code or some assets created by somebody else? There is actually a huge marketplace called the Unreal Marketplace, and you can access it through the Epic Games Launcher. So if I head into my Epic Games Launcher, head into Marketplace under the Unreal Engine section, you would see that you get a massive library of assets, and there are a bunch of free ones as well. Like I really mean a lot of free assets. So what if you wanted to use them? So that is where using plugins and other content packs comes in handy. So how you do it is really simple actually. So for example, I know one which is very handy. It's called Low Entry, I believe. Oops, low entry. So I actually have it in my library. So it's by this publisher actually. So low entry standard library. This is the one which I'm using. This is really useful. So once you search it up, and you can look it up in the marketplace, and there are many forums on Reddit and stuff talking about which plugins are good and stuff. So you can go ahead and install it according to your needs. So let's say I wanted some weapon models for prototyping. You could just type in weapon and you're going to get weapon packs. The way you install it is by clicking on this install to engine button. I've already done that, so that's why it shows that I can't. Now over here in my plugins panel, now I should be able to access it over here under installed, or if you just search it up, you would be able to find it and you can enable it. So low entry extended standard library, and I need to restart the editor. So let me go ahead and do that. Now that it's done, I can go ahead and use the content in the plugin. Now, how do I know what content is there? There will actually be a documentation and source code and stuff available. So you could just look it up. So there will be a place where the documentation is given. So you have a preview over here. Then you also have access to the source code and a bunch of stuff. You could also take a look at this over here. So maybe let's say we wanted to use some function here. So for example, I type in is debug build. Let's say I wanted to see if I am currently in a debug build. So I can type in is debug build, debug build, and as you can see, I can use the function. Now this was a plugin which has to be installed to the engine. However, we will also look at other types of plugins, such as, let's say I type in weapon, for example, I needed a weapon pack. So I actually have some in the library. You could find a free one, so you can head under free and you can look for it. But again, now in my library, I actually have some weapon packs. If I want to install those, it's actually really simple. So FPS weapons bundle, this is one thing which I have. So I can go ahead and add this to a project, and it does say none of my projects are compatible, but plugins like these, actually it doesn't really matter if you're using a later version than what is supported. As long as you're using a later version than that, it should be totally good to go. So click on show all projects and you can go ahead and select this, and you can change the version to the latest available one, and you can go ahead and add it. Now, just another thing, in case you don't have a plugin of this sort, so the one which we saw last time. So let's search for low entry once again. So let's say we have a plugin of this sort, which you install to the engine, but you actually don't have the appropriate version. So the way you'd actually go about upgrading your version is actually really simple. People haven't made any tutorials on this. I don't see any forum or anything talking about that either. So basically you just come into your Unreal Engine installation directory. So I go to program files, Unreal Engine, this is where I have it. And over here under engine, plugins, and the marketplace ones will be in the marketplace. And for example, I go to low entry extended standard library. I can right click on this U plugin file, and I can actually open it with any text editor, or I can open it with something like VS Code. So I'll open it with Visual Studio. Inside the U plugin file, you should see something a little like this. So you don't have to worry about any of these things. The only thing is the engine version. Let's say it was there for 4.27 and you're using 5, and if you want to make it compatible and let's say you're getting build errors, you could just go ahead and change 4.27 to 5.0.0. So let's say it was 4.27.0 by default, so you can go ahead and change it to 5.0.0. 5.0.0. So stuff like that. Alright, so that's about it. There isn't really that much depth to plugins. I mean, I will talk about creating plugins and stuff, integrating third-party libraries a bit later on in the advanced part of this course. But now let's go ahead and actually talk about a recently released tool, and which is quite handy in my opinion, and those are the modeling tools. First of all, in your plugins section, make sure your plugin is enabled. So make sure modeling tools editor mode plugin is enabled. And if you don't want to separately drag your model in the level and edit it, then you can press this as well. And now if you check your content browser, make sure you have some sort of a 3D model. Make sure you have some sort of a static mesh. So you can import that from your 3D software. So I just got one in from the engine content. So what I did was basically, actually I'll just go ahead and delete that and redo it. So delete that and delete this folder as well. Save everything. Now I just search for SM underscore. Usually it's a convention to name it SM underscore for static mesh. Under content, I just went ahead and created a new folder. So new folder, and I called it models. Open it up and just paste it in, just using the one from the engine content. Now you can drag it in the level and start editing it by heading into this tab right here and heading into modeling. So we have a bunch of options. The first few are for creating objects, but some of the useful ones are, for example, moving the pivot. So let's say you didn't want this to rotate along the center. You can go ahead and type pivot and you can move this point over here. Now if I rotate it, it's going to rotate along this point. And these changes are actually applied to this. So even if I just drag in another ball, these changes will be applied to that. So just be careful while using them. Of course, you can undo them at any point. So just save that. And sculpt is basically to deform the shape. So something like this. And again, you can use shift. The same principle works over here as well as we did with the landscape editing. So stuff like that. Then desculpt does a similar thing, just works a little bit differently. So I can just drag it like this. I'm not sure what I did there, but yeah. So I'm not really here to talk about the tools in detail, but just to give you an overview of how to actually use it. So you could experiment around with all of these. So if you type in accept, so now we have this shape. Obviously it just messed up with the UV map and the materials and stuff. But anyways, that was not our point. Now, a couple of useful things. First of all, creating shapes. So if I just type in stair over here, and if I head into this and I can actually make it a curved staircase, I can actually increase the number of stairs. I can decrease the step height. So I can increase the curve angle, for example. Then I can decrease the step height. So I can make it something like 10. Maybe place that and type in complete. Now if I go ahead and press play, you would be able to see that I can actually use my stairs. So that works well. So stuff like that. And now shapes are pretty obvious. Obviously, just create a box, do stuff with that. And now you might be wondering where these are stored. Over here, just check what is selected under this, under the new asset location. If it is selected to global, in your content folder there should be a underscore generated folder. In my case, it was set to world relative. So wherever you have your map, over here you should see a underscore generated folder. And if you open it up, you should be able to see your static meshes. So for example, we have this stair which we just created and we can drag this in. So this is going to come in really handy for many people, in my opinion. Now, not only that, it provides us with several other cool features. I'll just showcase one of them actually. So if you head into your modeling tools once again, so I'll just close it and open it up again. So I'll open up the modeling tools. And if I type in poly extrude, you can actually draw a shape. So if I just click somewhere, drag a point, do something like this, and if I join them, now I would be able to create something like this. So let's say you wanted to create a castle wall or something, you could do that. And the good part about this is UV map by default. You don't have to actually UV map it. The UVs are pretty good. So you can directly go ahead and apply a texture and it is going to look decent. Generally, if you create a weird shape like this in a 3D modeling software, you separately have to go through the effort of UV mapping it so that the textures don't look distorted. but in this case you are good to go. So that's about it for the modeling tools. So you can mess around with those. These are really, specific to what you're doing. So according to what you would need, you would use the appropriate tools, but it is there. Now even over here, you can change the pivot point, let's say for example. So I'll just show you guys once again. So modeling, if I select pivot, and if I move this over and press accept, you would see that the pivot point moved over there. So that's about it. So let's move on to the next part. So what I'm going to be talking about next is kind of the basics of what we did till now. So basically we worked with these models over here. Basically these are called static meshes. So any and all 3D models which you get in the engine without any sort of animations or anything, those will generally be static meshes. Any mesh with some sort of animation is going to be a skeletal mesh basically. So stuff like characters, gun models, and those are going to be your skeletal meshes. Anything which simulate physics or which does not have animations. So for example, this staircase, maybe a weapon model in a pickup blueprint, stuff like that are going to be static meshes. So they are recognized by a light blue color in the content browser. So if I head into models, you see it has a light blue color coding, and this indicates that it's a static mesh. Now we will dive into skeletal meshes a little more in depth later on, but for now I'll just head into static meshes. There are a couple of things which I would like to cover. First one is enabling nanite. Now if I head into wireframe mode, so now I can actually see all of the vertices in space. Now say I have many of those spheres, and in this case I have more than 6000, so 6480. So your first question over here is, how's the performance still this great? That is thanks to nanite. So if you right click on your model and enable nanite over here, if you right click and click on enable, you will enable nanite. Now if I go ahead and disable this, you would see that the performance dips immediately. So that's one thing about nanite. So as you can see, it's really not playable at this point. Now obviously this is highly unrealistic, and moreover it will depend more on your computer as well. So if I go ahead and enable nanite now, and if I press play, as you can see, even with so many spheres right in front of me, it's absolutely not affecting performance. Now we are not here to talk about the actual technology involved in nanite, so that's the reason I'm not telling anything else. But this is basically it. Currently in 5.0.3 there are a few limitations. For example, let's say you wanted to use this on a tree, you probably cannot, because trees contain leaves and leaves used masked materials, and those are not yet supported on nanite, but they will be supported in 5.1. So very soon you would be able to use them. So that's about it. There are a few material features which you can't use, and we will talk about materials. So stuff like dithering and stuff, you will have to just disable those nodes if you want to use nanite. But for most objects, so stuff like walls, or maybe if you have an insane level, something like this, nanite is going to come in handy. So that's about nanite. By now, one thing that you would have probably noticed is that any and all objects in the scene actually have some sort of a material on them. So for example, this has some neon blue texture on it, and it seems to be glowing. And this box right here has some sort of checkerboard, and same with the ground. So what's up with that? So basically those are materials, and that's what gives the color and all the other roughness related properties of a given surface. Now let's actually go about seeing how to create a material and apply it on objects. So let's just use a cube for example in order to demonstrate using materials. So let me just grab in a cube and I'll just place it in the scene. Now this has a material, basic shape material. You can actually explore this by clicking on this search icon over here. So you'll actually go to the directory where the material is stored. But in our case, let's create a new folder called materials, and let's go ahead and open it up. Right click and create a new material, or you can head into materials and create a new material here. Now the most important ones are just materials and material instances. The rest are just stuff which you might need in specific circumstances. So we'll take a look at material, and let's call this one our material. Now applying a material on a surface is actually really simple. Now we aren't going to be dealing with multiple materials on a single object in this part of the course. We will try to deal with it later on, but for now we won't be doing anything. So by default you get this checker material, so I'll just drag this in, and you can, in order to apply it, you just drag it basically on the surface. That's how you do it. Or if you want to apply it to a static mesh in general, so let's say I wanted all of the okay, whatever this object is, so let's say I wanted all of this object to have our material. So what I do is I'd head into the static mesh, and over here I'm going to select our material. So let me go back. So all content materials, our material, you can select that and you can click on this arrow icon, which will use our material. So now it's actually using our material. So we haven't seen any change because we don't have anything set up in the material. But the way you actually start working with this is by using these nodes. So this pin right here is, as the name suggests, the base color. Now how do you define a base color? So the most basic node over here is going to be a constant. So whoops, I press C on the keyboard. I'm supposed to press 1 on the keyboard and left click. And you see you get this node here which allows you to enter a value. Now generally you would enter a value between 0 and 1, but in some cases you would enter higher and lower values. So in this case, if I just plug this in the base color, and you can see it's compatible, so you'd see that our material is fully black. Now it's just a fully black material. What if I increase this a bit? Now save that again. As you can see, it became a lighter shade of gray. So 1 is going to be white. So this is basically a gradient. 0 is black and 1 is white. What if you wanted to give a color? So you'd hold 3 on your keyboard and left click. Then you'd get something known as a constant 3 vector. This is basically your R, G and B values. So red, green and blue. So you can go ahead, if you wanted red, you could do 1 on red. And as you can see, you get a red color material, and it's applied to all the objects which are using our material. So that's about it for base color. Now if you want to bring in any textures, I recommend this website called CC0 Textures. So open it up. Now it's renamed to Ambient CG. Keep forgetting about that. So if you just head in, and you can just grab in any texture. So I'll just grab in the lowest resolution one, so I can open it up in my folder over there. And over here I'll just drag it into images for now. I just have it set up like this. So I'm just going to extract it. And over here you see you get a bunch of textures. If you want to import it in the engine, it's really simple actually to import any asset, be it textures, models or whatever. So we'll create a new folder and we'll import it. So textures, open it up, and if I go ahead and drag this, for example, so I can just select all of these and I can go ahead and drag this in my content browser, and we can go ahead and save it. Now if I want to apply this texture to this material, now first of all we'll see which one is the base color. Sometimes these textures are labeled as albedo, but albedo is basically a base color without any sort of shadow related information. That's basically what it means, without any other sort of detailing. It's just the raw color. So if I drag this in the base color, I can do that. Now you could do this as well, totally fine. So this is how you bring in a texture. Now if I go ahead and look into my level, you see we have this wood texture on our little wall here. Now what if I wanted to tile this texture a little better? Now let's say I wanted to make this bigger or smaller. You'd use something known as a texture coordinate. So you type in text coord and you're gonna see texture coordinate. Plug that into the UVs. And now let's say I press 0.1, your texture will now be scaled 10 times. U and V are basically like your X and Y, to be very vague. Now we zoomed in way too much, so let's make 2 now. So now you see it's going to be more tiled. So now if you would see, you would have a more tiled material. So if I make this 3 for example, and if I go ahead and save this, you'd see that it'll be even more tiled. So I can make this 3.5, I can increase the value and it's going to be more tiled. So I can click apply, save, and I should be able to see there are more number of bricks. Now I'll just set this to 1 once again and save that, and as you can see it's applied to our level. Now this may be fine, but what if you wanted more details? Let's say you wanted to make this very glossy. So in that case, you can use the roughness node. Now the roughness is basically a 0 to 1 value, so you can again use a constant if you want. So 0 is going to be fully reflective. Now you could use the specular channel as well, but most of the times you'll only use roughness. It's very rare that you will actually mess with the specular channel. So now if I go ahead and apply this, you'd see that it's very glossy. And if that's not really that clear, drag in a point light, just move this, and as you can see it's reflecting everything over there. You see the little point over there, so that's showing roughness 0. Now if I change this to 1 for example, and if I hit save, you'd see that it's not reflecting the light at all. So that's the use of the roughness channel. Now obviously this is some sort of a wood floor texture, so obviously it will be depending on the grains of what's there over there. So how you would set it up is by using a roughness map. Now generally in websites such as CC0 or ambient CG now as it's called, you would get something known as a roughness map. Basically the brighter parts of the image are where the light is reflected more. The darker parts of the image are where light is not reflected. So let's say there is a fully black area here, so that's where all the light is going to be reflected. So I might have told it the other way around. Basically, the more bright the color, the more the roughness. Now if I drag this in, use this in the roughness channel, as you can see this gives us a little more definition. Now as you can see at the borders over there, you can clearly see that the roughness map is doing something. So this is about roughness. Similarly, normal is basically your depth. So as you can see, this texture, although it has a bit of roughness, it looks completely flat. Now if I go ahead and add in the normal map, so if I just snap this to the left and bring in my Unreal Editor on the right, and if I go ahead and apply my normal map here, and if I hit apply, as you can see, you'd see a little bit of a depth over there. Now if you can't really see it, that's probably because this is pretty subtle. So you can use something known as a multiply. Basically it's just going to multiply the value of each pixel in this texture. So multiply this, you can use a constant or you can set the value over here itself in the multiply node. So if I type in 100, let's say, for example, so now you would be able to see a little bit of the depth over there. But since this sort of a texture isn't really containing much of depth, so you won't really see it. There are other ways to increase the depth of a normal map, but that's not the point of this tutorial. So basically normal map is for your depth. If you're into PBR rendering, you'll probably already know all this stuff. Ambient occlusion is basically like your depth in your crevices and stuff. It's kind of hard to explain it. There's actually a comment here. So simulate the self-shadowing that happens within crevices of a surface. Basically, that's what ambient occlusion is. So in stuff like trees and rocks, ambient occlusion is something which would play a major role. In this sort of a texture, it's really not going to do much. So this is about the basics of materials. Now, obviously, this is completely wrong because we only have a texture coordinate for that one texture. So make sure you plug everything in. So just plug everything in. Now, if you go ahead and apply and save that, now you'd be able to see that it's applied properly. This had a subtle effect from the start itself, so that's the reason you couldn't really see anything wrong with it. So we created a basic material here. Now for any of these you can actually use your constants, but most of the time except base color you won't be using constants, you will be using textures. Now that's the very basics of materials. There are a lot you can do. Let's say you wanted to make this thing glow. So let me just remove all of this stuff. Let's say I just wanted a glowing neon green color. So let me just get a constant 3 vector. So the same right click search menu exists in the material editor as well. Drag that in the base color. And what you want to do is first you can grab in a constant and maybe let's say you have 10. This has to be a value greater than 1. So let's say I have 2 for example. So now you'd see that it's completely glowing white in color. Now if you wanted it to glow in this color itself, what you'd do is you'd actually get this and you'd multiply this by 2. So you'd multiply this by 2. Now if I go ahead and press save, you see it's glowing in a sort of green color. So this is basically called an emissive material because it emits light and it's pretty cool to look at. By adjusting the value you multiply it with, you adjust the intensity. Now one problem which you might have noticed here is every time we want to change a value, so for example we want to make this less bright, let's say 1.5. Now every time we have to apply and save this. What if we could dynamically change this? That's where material instances come in. It's basically like your derived class in your C++ inheritance. But to put that in short, basically you create another asset known as a material instance, which is subordinate to this material, and you can edit all the parameters in it. So I can right click on our material and create the material instance, and let's just keep it as the engine has suggested. Now instead of applying our material, we'll apply our material instance. Nothing has changed obviously. However, if I head into our material instance, now I can change the parameters over here. The first thing you might notice is there is nothing to change. So how do you do that? Basically, you'd have to head in here, right click and convert it to a parameter. So any constant or any texture which you convert to a parameter will be a value which you can change. So this is going to be called brightness, let's say. Brightness. And this one is going to be called color. So right click, convert to parameter and call this one color. Now apply and save it. Now if I open up my instance, you'd see that you get 2 parameters and now I can edit them. So now if I press 2, you see the changes are live. So 0 works, 1, 2, 0.3. So I can adjust my values just like this. And I can change the color as well. And it's updating dynamically. So for the most part, you'll be using material instances for this purpose itself. So these were the basics of materials. Now you could tinker around a bit, look into the documentation and create something yourself. Now we haven't talked too much about the other type of mesh, that is the skeletal mesh. So let's talk about that now. Now if I go ahead and press play actually, you'd see that we have a character over here which is moving around. Now the animations aren't actually complete. If you were to notice, he's just sliding around, he's not actually doing anything. Now how do you define the logic where, if you're moving above a certain speed, maybe let's say you start moving, you want to play an animation. How do you define that? So that is where you use an animation blueprint. And that is what I was searching at the start of this course when we actually did the character. So head into your character. Over here, one thing that you would notice is if I just head into mesh and if I just click on the search icon on the animation blueprint, it actually takes us to a folder inside the engine directory where there is an animation blueprint which actually does something over here. So this is how the animations are actually controlled, and we'll create one from scratch. We can reuse these animations, no problem. So head into your content folder, not the engine, so content, and for now we can just head into our models folder, and over here let's assume we had our character here, so let's call that tutorial character, because I guess that's what it was called, tutorial TPP I guess. I'll just open it up, right click, create under animation, create an animation blueprint and select the skeleton. Now I'm assuming you have a little bit of knowledge of what's a skeleton, what are bones and stuff. So at least that much would be required if you want to understand this. Basically know that each joint which you have, each point which can hinge basically is going to be your bone. So if I'm not clear about that, if I head into the actual skeletal mesh, so if I head into this one, so I'm not sure what it's called, and this one let's leave it at new anim BP. So let's TPP I guess. So this is the skeletal mesh. Now if I were to just click on this and if I head into the skeleton view, you'd see, for example, this is going to be your index. So if I rotate it, you can see that we can actually control it. Index 2 is going to be the further part of the finger. Stuff like that. I'm not actually applying these changes, so that's totally okay. And for example, if I take the pelvis, I can go ahead and rotate the entire thing because that's the root, that's the reason it's happening. If I take spine, it's gonna rotate the back. Stuff like that. Let's say you wanted to rotate it a little something like this. So you could make him bend forward, stuff like that. So this is a skeletal mesh, and output pose over here in the anim graph, as soon as you open the animation blueprint, this is what determines what pose you're in. By default, it'll just take a T pose or whatever pose it was in when you imported the model. So let's apply our animation blueprint to our character. So head into your character, select the mesh, and for the animation blueprint, let's select new anim BP or whatever that was called. So new anim blueprint. So as you can see, we are stuck in a T pose right now. And let's start applying animations. Now, in order to add an animation, the most basic way you could do it is you can simply drag in this animation and you can play it. So this is going to be the idle animation. And these are animations which the engine has provided, so I haven't really done anything here. So if you have your own character, you would have your own animations. But as you can see, there is really no logic that you can define over here. So the way you do that is by, first of all, we can start by creating a state machine. This is the most basic thing you can do in an anim blueprint. So basically you can use your variables over here to determine logic on how to change between animations. Let me show you with an example. So we'll just leave it at new state machine for now, or we can call this one walk run, maybe idle walk run, let's say. Just name it appropriately. And now if I compile, I'll be in a T pose again. Now entry is where you'd start. So obviously if nothing's really happening, you would want to idle. So head into tutorial idle. If you were to notice, it just outputs the animation pose. This is something like your return node basically. Head back into your idle walk run state machine. Now if I compile, as you would see, it's playing the idle animation, and if I press play actually, this is going to work. Now we want another state, so right click, add state, and this one is going to be called walk/run. Now, this is a shortcut way to do it. Like, I'm not doing a separate walk and run phase. I will do a separate walk and run state after I do this. So we want to be able to transition from idle to walk run. So drag in an arrow. And when we stop, we actually want to be able to go back as well. And I will show you what I mean by that. Now if I head into walk run, and if I drag this animation, you would see that he's not actually heading into walk run. So what you can do is you can just set this to true, for example, and you would see that he will be in this walk run state. So what this basically is if this boolean is true, the character will be able to transition from this animation to this basically. So how do you do that? We can actually set up some logic here. So we can say is moving, for example. This is not how you do it. I'm just showing you guys the basics. So if he is moving, we want to transition to the run phase. So idle walk run, we have that. Now in the event graph, we'll actually set up the logic to get is moving, because remember we only have the variable, but we're not actually setting the value. So every time the animation updates, so that's going to be every frame, what we can do is we can try get pawn owner. Basically that's going to be our character reference, and we can cast it to our I don't know what it was called, BP character, I guess. Cast it to that. Don't do a cast on update actually. You can actually do it on, I guess it's called start. There's an equivalent of begin play actually. Event blueprint begin play. So on this node you can actually cast it and you can store a reference and use that. Don't cast to it every frame, it's not efficient. So you can promote that to a variable and call this one character reference. So character reference. And once we have that stored, what we can do is we can use that if this is valid, of course. So convert to validated get. If our character reference is valid, what we'll do is we will get the speed. So how you get the speed is by getting the velocity. So velocity, get velocity, and we are going to get the vector length. And if this vector length is greater than 0, it means we are moving. So now if I compile, you see he's idle. But now if I press play, if I start moving, you see the animation triggers. But now he's not going back. And that is where the transition comes in. We have set up the logic to go from idle to walk run, but the engine doesn't know when to come back. So a very simple thing you can do is put this back. And if he is not moving, so you can type in an exclamation. So if he is not moving, then we can go ahead and transition back. Now if I press play, as you can see, it's working just fine. Now there are only two animations here, but what if you wanted to blend between them? What if you wanted a walk phase, let's say? So the way you do it is by using a blend space. So what a blend space is basically transitioning between two animations. And I'll just show that. I'm not really going to talk too much in depth about animations and stuff, but I guess you guys kind of get the basic idea. Let's say you had like a jumping animation. So what you would do is you'd have another boolean for the jump state, and in this state machine here you'd create a new state and call this one jumping, and then you'd transition from this and you would go back, stuff like that. That's basically how you do it. And now if we wanted to set up our blend space, as I told you guys, so head into your models, tutorial TPP, and let's just right click animation and let's create a blend space. So now we can select a skeleton and we'll call this one walk run, for example. So walk run. If you have a separate walking animation, you can inject it in, but for now we won't. Now in the axis settings here, this is what you will actually be using. So your vertical axis is like your speed, Basically, I mean, it's a convention. You can interchangeably use this, but you can use the vertical axis as speed. So basically, you see the value 0 to 100, so that's what it is. So we can type in speed because we can use this name later on. And for the horizontal axis, we can call this one direction. And it's going to be from minus 180 to plus 180. Over here for speed, we can go 0 to whatever maximum speed. By default it's 600, so we'll go with that. And we don't have sideways animations. Otherwise, on the left here, you can place your sideways animations. I'll just show you with these ones. So obviously when your speed and direction is 0, you would be idling. And walk forward is going to be over here. Now if I hold down shift and if I walk through this, so whoops, so I must just leave that over there. So at 0 and 0 and hold control, actually hold control, and if you would notice, you're transitioning between the animations. So if I play, as you see, now if you're walking slowly, so let's say I leave it at here. So when my speed is 373 and my direction is whatever that is, this is how the animation is going to play. Now if you want this to change a little bit, you can actually increase or decrease the values over here. And smoothing time is basically for your transition time. So how long it will take to transition from one animation to the other. Generally I just leave it at 0. I've had no issues, honestly. Now in our animation blueprint, instead of this, we can use our walk run blend space. Alright, you can connect this blend space to the output. Now we would see that you have to provide the direction and speed, and doing that is actually pretty simple. So head into your event graph, and what you basically do is you grab your character reference over here, and from this we can actually get the velocity. So velocity, get velocity, and then from here we can get the vector length, so basically the magnitude of the vector. Alright, once we get that, for the direction actually, we have a node called calculate direction, which requires the velocity, and I will tell you what to do next. So we need direction and speed. So we can promote these to variable. So promote to variable, we can call this one direction, and we can call this one speed. And if the character is valid, we can set the direction and speed. Over here in the direction, for the velocity, we can just directly grab in this pin over here, and then what we can do is we can get actor rotation. Now if I hit compile, and if I go ahead and plug these in over here in my blend space player, then in my transition over here, so walk run to idle, instead of not moving, what we can do is we can get the speed, and if it is less than a certain value, so if it is less than, let's say, about 10, so then we'll enter this transition. Similarly, if the speed is greater than 10, we'll enter this transition. So if the speed is greater than 10, so then we can go ahead and transition into the walk run state. So once we change that, we should have our logic working. So now if I go ahead and press play, as you can see, the walk run animations are working. So that's about it. Now we have finished animating the character with some basic animation blueprints. So that's all there is to it. Obviously there are many more things you can do with this animation blueprint. Of course you can have sprinting as well. So if you would have sprint, you would have another state called sprint, and then you would plug it in according to what logic you want. Basically, all you have to take care of is when your character can transition into states, and make sure it's not going to be in two states at the same time. That's about it. And in the event graph, anything that has to update, so for example, the speed of the character, those can be done over here on blueprint update animation event. So now I think this is more than enough for blueprints. And I think with this much of blueprint knowledge, you would be able to make an entire game. Assuming, of course, you would be ready to look into the documentation a bit and look into what the various functions do. If you actually play around with whatever we did, plus look at a few extra functions, you can create an entire game. And now, for the more keen ones out of you here, we are going to head into C++ now. We'll be taking a deep dive into the more advanced features of the engine. Now, not to worry for those people who don't know C++, I will also be brushing through some of the prerequisites that you need in C++ in order to get started. Honestly, there's not much to do with the language. Most of it would just be function calls and stuff like that. So anyways, without any more further delay, let's actually start learning C++ for Unreal. Now I will be going through the basics now. Now let's just talk a little bit about the prerequisite knowledge of C++ which you'll need to actually understand the further part of the course. I do still recommend you learn C++ separately, but I will get you guys what you need for Unreal, because it's really not that important to know the language. More so you need to know the features which we actually will make use of in Unreal. So I'll just create an empty console application here. So it's just going to be a blank application with in the terminal. Now I won't even use this. I'll just use an empty project template. So I'll just search for empty in Visual Studio, of course. I mean, we have it right here. So just go click next, and doesn't really matter. I'll just look for a folder. So I'm just going to create it there and click create. So just leave all the settings at default. None of these would matter for now. Now, once I've created this, I'll just go ahead and set up the basic stuff which you need for C++. So first of all, you'll need a C++ file with a main function in it. So just for my reference, I'm going to name it main.cpp. And we need a main function. We'll not get into that now. So int main, and we're just going to return 0. Now I'll not get into this, but the feature which first of all we'll need is to include code from other files. Now if you want to do that, you would do #include, and inside angular brackets or inside double quotes depending on the situation, you would include the actual header file. So let's say I have a header file, so I'll create one. So go ahead and call this, I don't know, header.h. Let's just leave it as is. And pragma once basically means this header file will only be included once, so you won't have circular dependencies and stuff basically. But anyways, let's go ahead and type some code. So in order to create variables, that's the first thing you'll need apart from including. So including this header file is simple. So in double quotes you can put header.h, or you could even use angular brackets. Generally you would use that only for like standard C++ stuff, but both of them will work. So if you want to include header.h through this, you might have to add it in the include paths. So we'll not do that. We'll stick with this. So let's say something standard C++ such as IOStream. So I misspelled that. IOStream. I can go ahead and do this. Or if I have something standard C, for example, Windows .h, so I can do that. So for standard C++ libraries, you would not use .h. For standard C ones, you'll use .h. So for example, if you want CMath, that's going to be without a .h, or you could do math.h. This is the CMath library. So stuff like this. For now, we'll include header. So whoops. So header.h. Now this should work. And later on I will be showing you guys how to include Unreal headers. That's not an issue. So this main function I'd just like to go over. Basically your program is going to start from here. But again, as I told you guys, when you're developing a game in Unreal, you'd really not worry about the main function. That is handled in the engine. So if you actually go through the engine source, you will find somewhere where you have int main, and there'll be a while loop which actually runs the game. So we'll not talk about that. So let's write some code. So first of all, creating variables. And before we do that, one thing to note is that these are just text files. Honestly, you can put the same code in a header and a C++ file. It really doesn't matter. By putting .h, you just indicate that you want to include it as a header. So that's the only reason. Both of these are technically just text files and can be opened with any text editor such as Notepad, Notepad++, Visual Studio or Visual Studio Code. Honestly, doesn't matter. So if you want to create a variable, you can first of all head into CPP reference to know the basic types. But if you want to create an integer, for example, you type in int space your variable name. So for example, we'll have my integer. And if you type in equals, you can assign an initial value to it. You actually don't need to do that. You can do this a bit later as well. But you have to do it inside of a function or something. So if I just put my integer equals 12 and make sure you end everything with a semicolon, this is not going to work because even though you have this line here, you're not executing this at all. So remember I told you guys the program starts from the main function. So over here, if I put my integer equals 12, this is going to work. Why this works is because we have included header.h. So it's as if it just copied over all of this content and pasted it in instead of this hash include. Now similarly, you can have other types which we discussed. So you can have float x for example, and you can have many other types. So for example, if you wanted a string, you would put in std string. In Unreal you use fstring, but again, now you're getting an error. That's simply because you have to include string. So these are the few additional complexities which come with C++. So std string, my string equals, let's say, test string. And you can go ahead and set the value again, test string. So not sure what we call that. So okay, my string is what we called it. So my string equals, and you can assign any value to it, or you could even use the constructor for this. Anyways, this is how you create variables like this. Data type, variable name equals value. Value need not be defined, initialized as soon as you create the variable. You can do it later as well, but it's always a good practice to do it. Now one more thing is that these variables can be printed out, which you will not use in Unreal. You'll use the print string function to print it on the viewport. But in a console application, you do something like std cout, and you would go ahead and print my string, for example. Again, we're not using this in Unreal, so that's the reason I'm not really covering this. So the error is because we haven't included the header which contains this function. So you can go ahead and include IOStream. And if you go ahead and run a debugger here, as you see, we get 232 printed because that was our string. Again, if we just delete this part, you would see we will get test string. And we can also print my integer like this. So we get 12. So this is how you would go about printing stuff. And what if you wanted to write your own function? So what if you have like 10 lines of code and you wanted it to be called once? So basically you can create a function with this syntax. So if you want to create a function, what you do is you'd put the return type. Let's say we create an addition function. So our result is going to be an integer. So the return type is int space your function name. So in our case, let's just descriptively name it add. And in the bracket, you would put the variables which which you take from outside. So in order to add two numbers, we will need two numbers first of all. So we are going to pass two integers. So the same way in which you created a variable and in the same way in which you'd handle anything else, you'd just do int a comma int b. So you separate arguments through a comma. So what this basically means is when I call add, so when I say add and I put my parentheses, so this is how you call a function. So if you want to execute add, this is how you do it, and you'd end it with a semicolon. Now inside the bracket, you would put the values of a and b. So in my case, if I just put in 12 and 43, or I'll just take some random numbers. Now the result of this is going to be returned here. And in fact, instead of, you can set it inside the variable. So if I do my integer equals add of 1342 comma 43, so whatever value will be returned here, that will be set inside my integer. Now if you want to actually write the logic for this, so you'd simply do return a plus b, something like this. So this is how you do a function, but honestly you don't need the syntax, since we actually have a simpler way to actually write functions. We'll be using classes mostly, so you shouldn't really bother too much about all this. And with that being said, let me just show you guys how to create a class. So I'll do it in my header. So for example, I'll just do a class called student, and I'll open up my curly braces. Just follow along with the syntax, it's just a matter of getting used to it. So under private, so these were the private variables which we talked about in Blueprint as well. So I can say we have a name, and let's say we have his marks, so int marks, something simple like that. And under the public section, we can have some methods. So we can say std string, and we can call this one get name. And instead of writing the definition over here like this, so this is similar to what we did here, it's just that it is inside the class now. What we can do is we can only have the declaration here like this, so only the name is given here, but we can actually have it defined outside this class itself. So I can do this, and I can go ahead and actually make another function. So I can say int get marks. So now you can also go ahead and define this outside the class. How you do that is you'd use this syntax. I'm not talking in depth about this, mostly because there's a shortcut to do it, which I will talk about. So std string, and what was our class called? Student, followed by two colons. You do get name, and you can write your function definition over here. So you can go ahead and return, I guess it was called name, so name. And similarly, you can provide a definition for the marks as well. So int student get marks, and you can go ahead and write the definition for it, return marks. So basically you're going to get the marks from this. Now if you want to instantiate a student, so let's say you wanted to create a student object from this. Remember we talked about classes and objects. So you just do student, let's just call him S1 for example. And you can do S1 dot get name. Now dot is what you'd use to refer to the members inside a class. In Unreal though, when you create objects, you generally have a pointer to it. So basically the memory address of it is a pointer. Nothing much to worry really. So I'll just show you guys a way to create it. So if I type in student pointer instead equals new S1. Basically we are dynamic new student. So new student. Basically, we are dynamically creating this, and instead of the actual variable name, we have a pointer to it pretty much. Now, nothing much to worry about. You just put a star instead of just referring to student. And if you want to refer to something through a pointer, you do S1 instead of putting a dot. Now, if you were to do dot, you see it just got replaced with an arrow. So you'd refer it with an arrow. So something like this. So if we actually just create a method to set the marks, so I'll just do void set marks, and it's going to be int the parameter which we need, so int marks. So we'll take this value from outside, and we can say marks. Okay, we are using this again, so we can type in marks with a lowercase, so marks equals marks. So what we can do is we can say s1 dot set marks, or rather with the arrow set marks, and we can just say 56 for example, just a random number, and we can print it by typing in stdcout, and we can print this. So run a debugger, and as you can see we got 56 printed, so we successfully set the marks. So this is how you would call functions which are defined inside a class, and you will need to call them through an object because you need to instantiate them first of all. This is something which you will not do in Unreal. You would use the functions such as spawn actor and stuff in order to actually create objects. But anyways, this was just something I showed you guys. Now with this much you can pretty much do it. If there's anything else such as for loops and stuff, you can just follow along and look at the syntax. That's pretty much it. And if statements are also easy, so you just do if, and you would have the condition in the bracket. So let's say the marks is greater than 56, so I can do s1 get marks, s1 get marks greater than, let's say, 35. Then we can go ahead and print that the student has passed, so stdcout, and I can say passed. So if I do this, as you would see, we get 56 and passed. Obviously this is not in a new line, but that's pretty easy to do. So you can do stdendl, and now you'd see 56 passed. So with this much basic C++, you can actually follow along, but again I do recommend you separately learn a bit of C++ before you come in. The upcoming sections of this course is going to be for intermediate and advanced users. So before you actually get started, I recommend you guys do a few things. First of all, spend maybe a few days actually exploring the engine a little bit more, maybe creating a tiny game or something. And secondly, make sure you do know the basics of object-oriented programming in C++. So stuff like your classes and stuff like structs, functions and variables, and the basic stuff basically. If you guys are familiar with that much of C++ and you have used the engine a little bit, you would be able to follow along with the further part of the course. So in order to start coding in C++ for Unreal, head into Tools and open your Visual Studio project by clicking on that button over there. And you should be in some sort of a file over here. Now you may have something blank, so we'll just close that. Now under your games folder, you should see your project name here, and this is where you actually start working with stuff. Now we don't have anything actually under this. We are going to be having our source files. So you don't actually create it here in Unreal. In Unreal, you actually have the option to just generate all the boilerplate code for you. You can do that by heading into Tools and by typing in New C++ class. Now over here, you get various options. Now if you have something really simple, if you have some pure C++ logic, you could just create an empty class and you could just tinker around. It's just going to create a constructor, destructor, and it's going to write the class definition for you along with no macros. just the standard C++ one. But the most basic useful thing that you'll use in Unreal is going to be your object. So under all classes, if you select object, this is going to be equivalent to your object in Blueprints. However, when you actually create it, so if I just create it, just select public, and this is just to determine where your CPP file will be, whether it will be in the public folder or the private folder. Now over here we can just call this CPP object. So let's not confuse ourselves. Let's just call it CPP underscore, yeah, object is fine. So this is not an object, this is the class which is named CPP object. Please don't get confused with that. So create a class, and now as you can see, you have some really basic code. And one thing you might have noticed is, okay, live coding is on, that's a different story. But what you might notice is it already has several things, such as it has included some header files here. These are just Unreal standard header files, and you will need them. And you might have seen a few extra macros as well. So this is a uClass macro, and inside these actually take in arguments too. Now these are useful for the Unreal header tool. Basically when you compile this, it happens in two phases. Basically your Unreal header tool sets up stuff which are specific to your objects for Unreal called uObjects. And in order to implement those features, it does certain extra steps. So when you get a compiler error, it could be either from that or from your standard C++ compiler. Anyways, that shouldn't be much of a problem to you guys. Now, if you might have noticed, even though we called it CPP object, it's prefixed with a U, and we have inherited it from uObject. Now, why is it like this? Now, basically any object that you create, that is a derived class of uObject, must have the prefix U, and even object has the prefix U. In Blueprint, it is just shown as object. However, in theory, it is actually uObject. And similarly for actors, so let's actually create an actor as well. So we can head back into the editor, tools, new C++ class, and as you can see, you see pretty much the same stuff over here. But these are the two important ones, object and actor. Now obviously character, pawn and stuff like that are important, but they don't have any specific prefixes. So I'll be talking about them a bit later. And obviously we'll talk in depth about the inheritance hierarchy. So I'll select actor. And let's call this one CPP underscore actor. Create that. And live coding, if it works properly, it should in theory compile it for us. Now if we actually open it up and reload this, you would see you find something which looks a little bit overwhelming if you're looking at it from the first time. But if you ignore this macro and if you ignore this comment here, I don't even know why this comment exists, because if you come to an extent where you can write or interpret this code, I don't think you need to know that a constructor sets the default value. So we'll just delete that comment. And begin play is basically your event begin play in Blueprint. Same thing. Tick is again your tick in Blueprint. You can delete the comment. Now this code looks a lot more cleaner. Now this is a virtual function. And if you were to notice, it's not called CPP actor, it's called a CPP actor. Basically every actor is prefixed with an A, and the actor class itself as well. Alright, now that we have established a basic understanding on creating a Blueprint equivalent actors and objects, let's look at the inheritance hierarchy in Unreal in a little more detail. Now I'm not covering everything over here. Now I have left a few things such as interfaces, and I'm not going into each class, I'm just talking about the ones that you'll use in almost every project. So that should cover things for you. If you need anything in specific, the documentation should help you if you understand this much. So at the base level, you have uObject. Of course, you have your typical basic C++ class, but we are not getting into that. Now under that, I can categorize these into three main other classes which you'll use. Now there are many others, but you won't really use them. The first one, and which you probably expected, is a actor. Now an actor, or a actor as it's called in C++, is something which can be placed in the scene. So if you want to place something in the scene and write the code in C++, you would create an A actor, or in the menu or in the Unreal editor, it's referred to as actor everywhere. Now similar to pawn, you have a pawn, which is basically something which can be possessed by a controller. So basically you can control it, and it need not be you, it could be an AI as well. So maybe you could write some code for bots or something. So you would use pawn in that case. And if you have something specific like a humanoid character or something, generally for most of the things which will be pawn, you generally use character. So if you need a movement component and stuff like that, you would use character. Some functionality is already set up in your character which is not set up in pawn. So some things such as adding your controller pitch and yaw input, and many other functions which we will talk about as we use them. So that's where you'll use character. This might be clear. Now a controller is basically an actor which takes in input. Now you cannot place a controller in a level. Obviously, it sounds a bit stupid to place a controller in a level, but basically each player will have his own controller, and to be specific, he will have a player controller. If it's an AI or something, you have something known as an AI controller, but again, we are not getting into that. It's really not that common to use it. A controller will basically take your input. Now, although you can set up your input bindings in other actor blueprints, controller is the right one to actually hardcode bindings and stuff like that. Generally, when you create widgets which are not associated with your character, you'd create them inside your player controller blueprint. Generally, you create a player controller, you don't create a controller. And that's about it for what you'll use for the most part. And if we actually head into more gameplay oriented classes, you have A info. The reason I put this is because this was just a wrapper for these classes which you'll use. You'll never create an A info actor, so ignore this. This is just for your reference. Over here you'd see A game mode base. As the name suggests, game mode base, it's basically your game mode. So any code logic regarding your game mode will be there in this, and obviously it's really simple for me to just tell it like this, but once I take a couple of examples, it's going to be crystal clear for you guys. And there is also an A game mode class which is inherited from this, and it has some additional functionality. For the most part, we will stick with A game mode base, but again, you can feel free to use A game mode. Similarly, A game state base and A game state. Now you might ask, what's the difference between these two? The main difference is that game mode exists only on the server in multiplayer games, whereas game state exists both on the server and client. So things like match timers, which you would want all the players to be able to see as well, you'd have them stored in the game state, and maybe some other variables which you only want to use as a means of calculating something in game. So stuff which will only be there on the server in multiplayer games, or something which is core to your fundamental gameplay. So something like maybe switching to another level when you enter a place or something. I mean, it depends on the game, honestly. Can't just tell what you do with it just like that. But basically, game mode, game state work together hand in hand. Now there's one more actually called the player state. Now the player state is really special because this is replicated by default to all the clients in multiplayer. We'll talk more in detail about multiplayer later on, but for now, just know that player state is going to be kind of the class which you'll use for anything that all the players must know at all points of time. And generally you'd store info common to a given player which other players need to know. Stuff like your player name would be there in your player state because all other players need to be able to access your player name at any point of time. So I just gave you an example. You could be creative with it and do whatever you want. Now, one thing you might have noticed over here for the last one, which I'll talk about under UObject is, or actually two more. Game instance is, as the name suggests, your game's instance. So this is talking about your game as a whole and not anything inside the game. So instead of begin play, actually, you have something known as event init here. So let's say you call something off of event init that actually runs well before your level actually loads. So we'll look into examples again. If you have anything pertaining to the game which has to sustain between level transitions, let's say you move from your main menu to your actual gameplay level. If you want stuff to sustain between them, let's say you wanted a variable to sustain, in that case you'd use the game instance because the game instance will not be destroyed between levels. But when you transition from one level to the other, all the actors and all the widgets, everything else that you could possibly think of are going to be destroyed. Now, speaking of widgets, we have multiple classes here which you'll probably never even touch. Even widget, to be honest, you'll never touch in C++. It's very rare that you'd require a C++ class for a widget. So user widget is the class which you'll use. Of course, in the editor, it's going to be referred to as user widget. So this is how you'd create widgets, but honestly, it's too much of a pain to work with widgets in C++ for something that's just, very simple. You could just work with other blueprints and just have a blueprint widget which you'd interact with, stuff like that. So that's about it actually. Now the way you'd practically use this is you'd have one C++ base class. So for example, we can have, for a character, we can have one character and we can go ahead and derive one. So let's say we call this one R character. So let's say it is A, we'll just call it CPP as a convention, A CPP underscore R character. I'll just call it R char for now. Now what you do is you'd have core functionality written inside this class. So for example, your movement maybe if you have a first person shooter game, your firing logic, basically stuff that is mission critical for the game and stuff which would break if they don't execute. So for that you'd write it in C++. But other cosmetic things which you don't really require, and it's fine if it executes a bit late, stuff like, creating widget, maybe let's say you have a crosshair on the screen, maybe updating its position, if you have a dynamic crosshair that is, or maybe stuff which is not essential like FX, spawning FX. So if you have stuff like that which is not really mission critical, it's fine if it's a bit slow, and maybe if you don't have too many loops. So if you have many loops in your code, blueprint generally runs slower. I will talk about why that is and stuff. So what you do is you'd have the core functionality in your base class, and then you'd create a blueprint class which I'm marking in yellow, and you'll call this one BP underscore R char. Now this is just a convention I use. You could call it anything. You could simply call this one R char. So this is going to be our blueprint class, and this is what you'll spawn in the level. So since this is inherited from this, BP R char will have all the properties of ACPP R char. Similarly, you do that for all the other classes, and that's how you'd work hand in hand with Blueprint and C++. Blueprint is going to make your coding a lot easier. So it's basically your visual scripting language. So it's going to be very simple to write game logic. But when it comes to finer control and when it comes to using other libraries, when it comes to doing mission critical stuff, you would use C++. So that's basically how you use Blueprint and C++ hand in hand. Of course, this is a very in-depth topic and we are going to be talking about this in the future. Now let's actually go ahead and work a little bit more on whatever we learned till now. So now that we know about the basic inheritance hierarchy, let's actually start creating stuff on our own. Now, the first thing which you might want to create are variables. Now, For our case, just for reference, we'll be using our CPP object.h. But anyways, you don't have to use this. You can do this inside the actor as well. So stuff like that will remain the same. Most of the time you will not have anything in the global scope. You will create everything inside of your class itself. So the rest of your file, maybe if you are creating a new struct or something, you'd use it. But most of the times you will be doing stuff inside the class. So let's create a variable. Now you could do your normal C++ syntax thing. So for example, let me just create an integer. So by using int, let's say our integer variable. Alright, you could initialize it here or in the constructor. Now one thing that you might know is that since this is private, our derived classes, hence any blueprint class which we create out of this, cannot access a variable. So in order to actually access it, there are two ways. I'll be showing you guys both the ways. So I'll type in our private integer variable because we made it private. This is how you would ideally do it. I'm just explaining you guys each thing, but you could brush through if you are already aware of object-oriented programming. But anyways, it will give you a learning experience nonetheless. Now another way you could do it is you could create a variable in the public section. So we'll call this one our public integer variable. Now this is good if you want to access it everywhere. However, it's really not appropriate to do it this way, because if you have it in public, any other class can just straight up modify this variable, which is not good for us. Let's say you have something like your character speed or something. It's very easy to misinterpret that, maybe accidentally change the value, so it's better to have getters and setters instead. Now this is how you would work with a public variable. I know you guys are still waiting for the Unreal's reflection system. So all these macros which you see, uClass, uStruct, uProperty, I'll tell you about all those. Not to worry. Now another thing is that since this is private, in order for other classes to access it, we actually need to define a method. So we can call this one int get our private int. We called it integer over there, so let's call it like this. Now we also probably need a setter, so set our private integer. Now we don't have a function definition, so the reason I told you guys at the beginning that you don't really need to know too much C++ is that once you know how to write the declaration, you could just right click quick actions and you could just create a definition like this. Same way with our setter function. Oh, and this has to be void because we aren't actually returning anything. You could make it bool. So let's say you have a condition where you can't set it. So let's say for a health variable you can't set it to 101. So then you would do those checkings and stuff. But in our case we'll just use void. Head into the file here. And instead of this, we will return this variable. So not public, we'll return our private integer variable. Now this is how you would set it up for the private variable, and this is the proper way to do it. Also, currently none of these use Unreal's reflection system. Now if I just run a debugger, so it's going to launch the editor. Make sure it's set to development editor in the configuration. So wait for that to build, and once it's done building, it should start the editor. Now in order to actually use this over here and actually check stuff in Blueprint, so what you would do is you would right click, go to Blueprint class and type in cpp_object, but you see that it's not visible. Now the reason it's not visible, but our actor was visible, because by default all actors, if you were to go into this file, by default all actors are going to be marked as blueprintable. So if I actually head into the actor over here, and if I actually look into this uClass macro, you see it says blueprintable. So what we need to do is in our object, if we want to use this in blueprint, that is inside this uClass macro, type in blueprintable. Now this is how you expose your U objects to blueprint. So let's say anything is not accessible in this menu over here under all classes, it probably means you haven't marked it as blueprintable. So let's stop the debugger and run it again. So wait for it to compile. Then once the editor loads up, we should be able to use our cpp underscore object class. So give it a second for it to load. And now if I head back into blueprints, right click, blueprint class, cpp underscore object, you see that it's usable. And this one will call it bp underscore object. Now, if I just right click and if I want to access the function, so we have get our private integer. So get r, and as you can see, there is really nothing. The reason is Unreal doesn't really know that you want this to come in the editor. Basically, you're not utilizing the Unreal standard macros which enable you to do it. So how you do it is for variables, what you do for a public variable here, we are going to type in uProperty, and in the arguments, we'll use a parameter known as blueprint read write. Now, when you put this in the arguments, basically what you're saying is you want this to be readable and writable in blueprint. Let's say you only wanted to be able to read it, you do blueprint read only. Now, how do I know how to do this? Basically, you can just head into your browser and type in uProperty UE4 or UE5. Oops, not properties. So, yep, uProperty. So basically, you have to go to the documentation page, and as you can see, there should be a list of specifiers somewhere over here. There is. So all of these are the specifiers. So let's say you wanted a function to be blueprint callable, you do that. There is blueprint pure as well. I'll be showing you guys the common ones, but you can have a look at all of these. The documentation is king. Now for a private variable, actually we don't need to make this a uProperty. However, you could choose to make it. Now if you want to use these getters and setters, which will technically enable us to use our private variable, our get function will be pure, of course. So we are going to use a u function now. Now u function is another macro. Again, you could have a look at it. So here, if I head into u function over here, you see again there is documentation which talks in depth about this. We will be looking at the common ones anyways. This one will be blueprint pure. Blueprint pure means those green nodes which we saw without any execution pins. So if I actually head into any blueprint, these types of nodes basically without this execution pin, that's going to be our pure function. And I talked a lot in depth about it when I talked about blueprints and stuff. Now this one will be a u function as well, and this one will just be blueprint callable. Alright, now we can go ahead and run a debugger. Now we should be able to access these. Now live coding is a bit finicky. That's the reason I'm not using it. Otherwise I would have chose to use it. Now let me just create that. I didn't actually save it. So cpp underscore object. We'll call this one bp underscore object. Save that this time. If I open it up now and if I type in get our private integer, you see we get this function which gives us access to the value. Similarly, set our private integer also works, but it's kind of useless. We actually didn't set up any functionality. So let's just take in a parameter. Parameters are pretty simple except references. Everything else is going to be the same for parameters, like how you do in standard C++. So you could type in int new value, and over here as well we could just head into the definition and change that. And then we could do r private or r public, it should be, nope, it should be private. So r private integer variable equals new value. Now that should fix things. So we should have our logic corrected over there. But that's not really our concern right now. Now, what if you wanted to take a value by reference? Now, this is passed by value and it will work. You could try it out. Not really going to waste my time to show it. If you actually want your value to be passed by reference, you use this macro known as uparam. So uparam ref, and then you use an ampersand over here. So copy this, do the same thing in your CPP. And now if I go ahead and actually build this once again, and in my object, if I go ahead and type set r private integer, you see it's taking in by reference. If you hover over it, it says new value integer by reference. So this is how you do pass by reference. I just showed that. This is one thing which is a little different from C++. You can't just use an ampersand. However, if you use an ampersand, it is going to take it as a second return value in Blueprint, basically like your out parameters. So let me show you guys what I mean by that. So if I do this, now this is wrong. Logically, this is wrong. I know that. But anyways, I'm just showing you guys what's going to happen. So if I go ahead and run a debugger once again, this time it's going to take it as an output rather than an input. If I open my BP object again, and if I type in, let's say set r private integer, you see the new value goes out. Basically, this is how you handle multiple return values as well. You could just do pass by reference, and in Blueprint, it's going to interpret it as an out parameter. In our case, uparam ref was the correct choice, so we are going to do that. Undo this over here as well. So that's about it. Oops, just correct that. Also, if you guys want to access your public variable, you can just directly use our public variable. So our public integer variable, so it's directly accessible to us. But one thing you might notice is that unlike these variables here, it does not let you edit the default value and stuff. Now, there is one reason for that. That's because you again need to set a flag in order to do it. Remember the uProperty macro? Over here, you have to type in edit anywhere in order to be able to do it. So edit anywhere, if I can spell that correctly. If I actually do this and run a debugger once again, I should be able to use our public integer variable and set its default value. Now, if you were to see under the class defaults, we have an option to set the default value, or when we even get our public integer variable, you see that we can set our default value. So this is basically how you expose that to Blueprint. I suggest that you guys now try it with a few more functions of yourself and maybe, check how they work in the editor and stuff. Once that's done, let's talk about the next type, that is uStruct. So basically, if you want to create structs for the Unreal Engine, you need to use the macro known as uStruct. Now, generally, I prefer doing it inside this .h file for your project. So you will have a file like this, but you really don't need to. You could do it in any file. So for example, let me just do it in our cpp object.h file. It could be really anywhere. Unreal is going to recognize it for you. So I'll just do it above our u class. So I'll just type in struct. And if you guys don't know what struct is, well, you got to learn that before. It's basically like a class, but by default, all its members are public. But remember, when you're working with Unreal Engine, you don't really work with struct methods. You only work with variables, and any methods you'll have it in another class as static functions. So that's how you work with it. Anyways, I will show you guys what I mean by that real soon. So for example, let's just create a struct. known as, let's say, book. This is obviously highly impractical, but just as a basic example. And for the variables, we could have maybe a string. Now remember, in Unreal Engine, the variable you use is not std string, so you don't use std string actually. What you use is called fstring, which is Unreal's string type. Obviously, most of the string types are just interconvertible at any point of time. So if you're using a third-party library or something, you can convert it. So fstring is the string type in Unreal. So if I type in fstring, let's say name, and maybe we can have an integer for number of pages, and we can have a float for rating. Alright, we have a really basic struct over here. Now if I go ahead and build this actually, so I'll close my editor. If I go ahead and build this, you would see that it would build successfully. However, obviously, as you would expect, you cannot access this struct in the editor because we haven't used the Unreal macros. So in order to use this in the editor, you call uStruct, and inside the parameters, what you do is you would make this blueprint type. So this is what you use to expose struct to blueprints. Now if I actually run a debugger right here, so you would find that there are a few build errors. So what this is this is not your C++ compiler error. Basically, there are a few rules in order to use structs in Unreal. Similar to how you have a U prefix, for all structs you need to have an F prefix. So now if I go ahead and run this, in the editor it's going to be visible as book. You see that we get another error. Now it says expected a generated body. Now if you notice our class here, it has a generated body. Similarly, for our struct as well, for all uStructs, we are supposed to be having a generated uStruct body. So it's going to set stuff up for the editor for us basically. So now if I go ahead and build this, you should see that we compile successfully. And we open up the editor right now. But you will soon notice one problem again, which you probably would have guessed if you would have seen these. So if I just head into my object, for example, and if I type in, let's say I create a new variable and call this one book1, and I get the type book, you see I can access this. There's no issue. But if I right click, I can't actually split the struct pins. Now if you actually hover over this, cannot split the struct pin, it may be missing blueprint exposed properties. So what it basically tells us is we actually need to mark these as U property as well. So the same macro can be used here as well. So U property, and there's a little bit of an issue with the indentation there, don't mind. So U property again make this one a U property. Depending on what you want. Let's say we don't want to be able to change the name, so let's make that blueprint read only, so then we won't be able to change it. Now if I stop debugging and open the editor once again, now if I go ahead and take a look, and if I drag this in, right click and split struct pin, I am able to split it. Now if you drag this in and if you want to edit the members, you would use the set members function. And obviously you can have number of pages and rating as a parameter, and we set name as not being editable. Since we did blueprint read only, as you can see, we don't have that available as a pin. So this is basically how you use structs in C++. Now the way you use it in C++ is pretty much the same like how you would. By the way, if you want struct methods, you can use them, but you cannot write U functions inside struct. That's the thing. So if I actually go ahead and try it, basically, I'll show it to you guys. So if I head in here, type in, let's say, void test function, and I'll just give it a simple body here, and I won't do anything. Now you would see that it will build successfully. There won't be any issues. So as you can see, it builds. But if I actually make this a U function, I won't even give any parameters. If I just make this a U function, as you would see, it says U structs cannot contain U functions. So how do you actually do stuff with it? So how do you actually operate on structs? Basically, what you would do is instead of having the U function here, you would have it inside either a function library class or you would have it inside some other object and make it a static function maybe. So let me actually show that. So let's create a test function. So for example, let's create a U function here. So U function, and what we can do is we can make this blueprint callable. And over here, instead of just declaring a regular function, let's do a static function, static void test. And now we want to operate on this struct. So if you want to operate it similar to your objects, what you could do is you could simply create your own target pin. So the way you do it is fbook target, and obviously you would make that a reference. So U param, and in the brackets you would have ref. So you would pass this as a reference and then you could work with it inside. So I can write the definition here as well, but just to be a bit cleaner. So quick actions. So whoops, quick actions, and I can create the definition. And now that we've actually come this far, I'll just show you guys how to print strings. So it's not like Blueprint where you directly just call, print string, and this is not gonna work. So I can't just do this. So let's just say test function called, for example. I actually cannot do this. The very simple reason being that in Blueprint, Unreal actually imports or rather includes all your headers for you as per necessity. But basically that doesn't happen here. So it's not exactly headers, but you get the point. So in order to use print string, so how you would go about searching for functions is you do something like this. So you do print string Unreal C++. This is how you just search it up. And you would look for the one which says docs.unrealengine.com and you would head in here, and it tells you the include file. So copy this path, paste this in, not path, rather the include, and now you would see you have all the various parameters, some of which are optional. There are only 2 parameters which you actually need, but anyways, now what we can do is, now you notice that you're not able to call it, but that's because this is actually a static function once again. So what you do is you do ukismet system library and followed by scope resolution, print string, and now you'd see that it still shows an error. That's because you actually need to pass in a world context object, because it doesn't really know, where to output the string, like how to show it on the screen. So in order for it to know that, you actually need to pass in an object. If this wasn't a static function, you would just use this. So if this were inside an actor and it's not static, you would use this, but it says this may only be used inside a non-static member function. So what we can do is we can just pass in a uObject pointer over here, or rather we'll just pass in an actor pointer. So a actor pointer. Now remember, when you work in C++, any object, any actor, anything that you have which is enclosed in a class, basically any class, if you want to use them, you would use a pointer to it. You will never refer to it as a actor. It'll always be a pointer. Just remember that. So an actor is just to give, some context to it. So we can just type in context, for example. It could be an object as well, I assume. So if I type in context here, now we would see that the error is gone. But obviously we changed the function signature. You could make this a uObject pointer, I believe. And now what we can do is we can copy this over, head back into our function declaration and put that in. So now our error should go. Now if I go ahead and actually run this, now if I head in to blueprints and BP object, or here if I call test, for example, I think it's called test. As you can see, now we can operate on this struct, and for the context what we can do is simply we can plug any outer object in. So I'll just actually do that. So I'll open up the level blueprint. So for the context, what we can do is we can go ahead and get a reference to self. And for the target, what we would do is we would go ahead and actually get a struct. So instead of this, I'll just create a struct. So I'll just call this struct, for example, and it's going to be of type book. So we can use that, and now this function is going to operate on this struct. So this is just a basic way you can do it. Now if I go ahead and press play, after 3 seconds you should see something being printed, test function called. As you can see, that works. So that's pretty much how we would handle struct methods. So that pretty much covers the basics of using structs in Unreal C++. Now the next thing is obviously enumerations, and that should be about it, and then we can start working with a little more complicated things. At the base level, enumerations in Blueprint and C++ work the same, but in order to create them in C++, you can do the same thing actually. You can do enum. This one doesn't really need to have a prefix, by the way. So for example, let's just say fruit list, let's just call it. And inside that we can have our list items. So let's say we have apple, let's say we have our mango, and let's say we have a banana. Stuff like that. Make sure you just end everything with a comma. Now again, the same thing. This is not exactly exposed to Blueprint, but in order to actually expose this, you use the same specifier as your use struct, but instead you type in uenum. If you use the uenum macro, and if you add in the parameter blueprint type, now this would be usable in Blueprint. But if you wanted to give it a different name for it in Blueprint, so if you wanted to give a display name to this, basically what you'd do is you'd use another macro known as umeta, and over here you'd change display name equals, and you'd put in the string. So in our case, let's just call this one apple underscore 1 maybe. So just for me to demonstrate that it works. Now if I actually run the editor, and I can just go ahead into any blueprint and I can operate on that. So I can say switch on whatever we call that fruit list. As you can see, instead of apple, it actually shows apple 1, and mango and banana is just shown as is. Generally what you would do is you would simply have the display name to just display exactly what this list item was. So you would simply have this, and you would have mango over here. Generally you would just leave it like this, banana. So this is how you would go about doing it. Now we have brushed through the basics of Unreal Engine C++. Of course, if you want to know what function calls to use for your gameplay specific needs, you could refer the documentation. And later on, when we actually take an example, we will look into some of the common ones. So it's not really that you have to refer the docs for everything. I will be going through many of them. Now over here, let's actually do a quick exercise. Let's try to translate this into C++. Now if you were to notice, this entire thing is actually purely in Blueprint, and let's say we wanted our code to run faster, or for whatever reason we needed it to be in C++. So let's actually go ahead and translate that. So it's really simple. Let's start step by step. So we have our get player camera manager function. Let's see which header file we need. So it says target is gameplay statics, right? So this tells us that we need gameplay statics. So if I head into Chrome and if I type in gameplay statics UE4 or UE5, you see you actually get the documentation page. So over here we can get access to which header file we need. So Kismet gameplay statics.it. So stuff like that. Let's actually go about doing it. Now for the cast node, we need a C++ class because all our C++ classes will not have access to the blueprint classes, but all our blueprint classes will have access to the C++ ones. So you cannot access a blueprint class from C++. So that's one disadvantage. Now let's go about doing this. So I'm just showing you guys one example. Obviously, we will talk about a few of the common ones such as spawning actors and stuff, which are really common. Now, let's start in the editor. So let's go ahead and actually create the classes that we need. So first of all, we need a base class for our BP character. So go ahead into tools, new C++ class, character, and call this one CPP underscore character. Of course, you can name it descriptively if you wanted. Create the class, head back in, and we need a couple more things actually. So one thing that we need is the pickup class itself. So type in actor and call this one CPP pickup. Alright, create the class. Now what I want you guys to do is head into BP pickup, and over here under class settings for the parent class, I want you guys to select CPP pickup, and over here as well I want you guys to select CPP character. So CPP underscore character, I want you guys to select that. Now what this basically means is that you are inheriting this BP character class from CPP character. So everything that's there in CPP character will also be there in BP character. Basically this is your inheritance. Now let's head back in. Let's just reload this, and I think we can close the editor for now. Or actually we might need that for reference. So let's actually open up the character. So we need a player camera manager, and from our header file, from our documentation, we know that we need this header file. So inside our character.h, because that's where we wrote it. Always when you're including header files, you need to do it above the generated.h. So over here, Kismet gameplay statics.h, and let's just do this in the public section, and let's have a look. So when we press our left mouse button, we get the player camera manager. So let's try calling that static function. So go ahead. Let's actually create the function. Let's call this one, I don't know, what do we call this? So we're just tracing and destroying. So let's call this one remove pickup or something. So void remove pickup. Alright, we don't really require any parameters. Now let's go ahead and create a definition for it. So, whoops, let's just head in, and it has created the definition for us. So let's go ahead and get that. That's a static function. So you gameplay statics get player camera manager, and over here what we can do is for the world context object, since this is an actor, characters are actors, so you can just use this. Generally you would just use this, and player index is 0 since we have only one controller per screen. So we got the camera manager, and from this we need the actor location as well as the forward vector. So what we do is, let's actually just store it in a temporary variable. So we can type auto temp equals, and we can store this in a variable. And what we can do is we can go ahead and get the actor location. So this is a pointer again. So temp with the pointer operator, we can get the actor location. We have forward vector here, let's do that as well. And temp get actor location. Now this might actually warn us right now to use the get camera location function. So as you can see, use get camera location instead. So get camera location, just spell that correctly. And now we have access to these locations. And what we are doing is we are basically plugging this into the line trace. So what we can do right now over here to simplify things is we have a forward vector. We grab that in and we multiply it by a float. So the operator is already overloaded, so we multiply that by 50,000 in our case. So let's just do that. And if we head back into our blueprint, so we add that to our camera location. So plus our camera location, so you could just do a plus again. So plus our camera location, we can put these in parentheses just to be a little more clear on what we're actually doing. So we can delete this line. We have that. Next, what do we have is our line trace. So if you just hover over this, you see it says target is Kismet system library, and I know this header file, so I'll just do it for you guys. Anyways, what we are doing is going to be correct, so let's close this up. So it's going to be Kismet system library. You could have a look at the documentation as well. So Kismet system library. And if we include that, our error should go. And if I open up the CPP file once again, now we should be able to call the line trace function. So u Kismet system library line trace. If I do that, I should find line trace single. And for the parameters, we have a bunch of them. So first one is the world context object, which is going to be this again. And next we have the start and the end location. We look into all of that. So this, and our start location is going to be our camera location. So what we can do is we can actually store this in a variable right now. So what we can do is we can type in auto camera location equals get camera location. Now for the start, we can go ahead and type in camera location, and then we have our end. So again, we can store this in another variable. So auto end location, or let's just call this one end, equals whatever calculation we just did right there. So end is what we called it. Then the next parameter we have is a trace type query, which is the trace channel. So this is what you see over here. Now over here, this is a little bit peculiar in C++. So if I just do eTrace type query, so eTrace type query, and if I take a look, you get something like 1, 2, 3, so on. Basically, these are what you define in the project settings. So if I actually head into my project settings and just type in trace, you'd be able to see that you get trace channels. By default, we actually get two, that is visibility and camera. So if we just do trace type query 1, that is going to be your visibility. And then if we take a look, we have a boolean for trace complex. We don't really want to trace for complex collisions here, so let's just do 0, or that is false. And over here we have a parameter which we actually don't need, and we also have a few more, I guess. We'll just use the ones which we absolutely need. So actors to ignore, we can just create an empty array and we can just pass that in. So tarray a actor pointer, and I will get to TRAs, don't worry. Basically, this is like your std vector in standard C++. Instead of that, the one used in Unreal is called tarray. So all the same functions exist inside this as well. Instead of dot size, you have dot num. There are a few names which have changed, but this is pretty much like your std vector. And let's just call this one ignore, and we'll just pass that in. So ignore. And the next parameter is eDraw debug trace. So basically whether you want to see the line trace or not. So eDraw debug trace. whoops. And over here we have for duration for 1 frame persistent. Let's keep that for duration for now. Alright. Once that is done, we have our hit result which we are going to output. So we'll just create another variable. So f hit result, and we'll call this one hit or out hit or whatever. And what we can do is we can just pass hit over here. And once we have our hit result, we have b ignore self. Yeah, we want to ignore ourself and don't really need the trace color because this has a default value. So that's about it basically. So we can go ahead and close this. So I feel these parameters should be enough. And once this function is completed, we should have access to everything that we can possibly think of. So the first thing that we are going to do is we are going to cast it to the pickup. Now, in order for us to work with this, first of all, we need to include the header file. So hash include, because we don't know what CPP pickup is. So we'll just do CPP pickup.h. So this should compile because it is in the same folder. And once we actually include the file, what we can do is we can simply cast it. Now you won't use a dynamic cast here. Unreal actually has some things built in for us. So we can get our hit. So if hit dot actor dot get actor, if this is valid. Now at this point, if we haven't actually hit any actor with our line trace, basically this if is going to be false and we are not going to execute this code. However, if we have hit the actor, we can go ahead and cast it to our pickup. So if we can go ahead and cast it. So this is going to be a CPP pickup. This is how you cast in Unreal C++ basically. You have a cast function and over here we can just pass in the actor. So if this actor is valid, so again the pointer is going to be pointing to an actor if it is actually valid. In that case, what we can do is we can go ahead and destroy this actor. So hit.getActor and we can call the destroy function. That's about it. And just to make sure, what we can do is we can just print it. So ukismet system library print string, and over here we can just pass in this instead for the world context object, and we can print destroyed a pickup. And we can go ahead and terminate that. So now in order for us to actually be able to call this from Blueprint, we'll set up input and stuff a bit later in Blueprint. It has a couple of extra steps. So in order to expose this to Blueprint, we'll again use a u function and make this one Blueprint callable. Make sure I get the case right and just indent that. And now if I go ahead and close my editor and run a debugger now, the editor should load up, and if we open up our character, we can get rid of all this code, and I don't know what we call this. So we called it remove pickup. I don't even know why we called this, but we can call remove pickup. Remove pickup. Now if I go ahead and press play, and if I left click, as you can see, our logic actually works. And okay, this is not a pickup, this was just a cube, so that's the reason it didn't work. But anyways, the line trace works. Now the reason it's working is because BP pickup is also a CPP pickup because we inherited from it. So that's the reason. What's happening is when we actually cast it over here, we are actually successfully casting to our CPP pickup as well, even though that was a BP pickup. So that's basically how we translate it. Now we can go ahead and clear out some stuff. This was just for clarity. So instead of using the camera location as a separate variable, we can go ahead and copy this over. Similarly for end, we could just do the same. And if we have anything else, we could do that as well. So we don't have anything else. We can go ahead and close this up. We'll leave this temp variable because having such a long line everywhere is going to be a little bit weird. But again, you could do this. So you could just place this instead of temp. Wherever temp is going to be there, you could go ahead and get the player camera manager and do that. But in this case, actually using temp would be a better solution. So we'll just stick with using temp. So we have brushed through quite a bit regarding C++, and as we create stuff, we will go through more things. Now, what if apart from a pickup, we also needed to cast to some other thing? So let's actually create another actor. So let's do it with our interaction actor itself. So let's go ahead and open it up. Not sure where we've used it, so let's just hit Ctrl F to find, and let's just find interaction. So we are basically nudging it. So what we're basically doing is we are again casting. So I have to just check where it is. So if we are overlapping, so that's what we are doing. So let's actually remove this logic and let's actually have the destroy logic itself. So remove this and remove this, or actually we could keep this. Now if you wanted to do it with your cast, so what you would have to do is you have to cast to interaction actor. If this fails, and then destroy it, and this for the most part will work. So let me just go ahead and drag that in. Forget about the C++ logic, and as you can see, this works and even this works. However, one thing you might notice is, let's say in an actual game, obviously we'll have many such actors, not just an interaction and a pickup actor. So in that case, you will have to perform many casts, and casting is expensive for your computer's performance. So the way you get around this is, instead of casting multiple times, you could cast to an interface. And in Unreal Blueprint, there's actually a very elegant system implemented. We'll be talking about both the Blueprint and C++ versions of interfaces now. So in order to handle this problem, what we can do is we can actually create an interface. So I'll show you guys step by step to implement this exact logic using an interface. And we can actually have separate logic as well for both the interaction and the pickup actor. So head into your blueprints, right click, blueprints, blueprint interface, and let's just call this one, I don't know, destruct, I guess. Generally I have a convention of calling it BPI underscore, and we can call this one destruct pickup maybe. Alright, and we don't need anything for the input, but anyways, now the way you actually use this is for whichever actor that needs to be casted to. So for example, we are casting to our pickup and our interaction actor, so we would head into both of these, and under your class settings, under implemented interfaces, we can go ahead and implement BPI destruct. And do the same thing for the interaction actor. Head into class settings, BPI destruct. Basically, at the fundamental level, what this is doing is it is inheriting this interface along with actor. So basically your interface is also a class internally in C++. I will show you guys the C++ plus version, which will make things a little more clear. But instead of doing all this, what we can do is we can call destruct. Or I guess I called it pickup. So let's just call it destruct in general. To compile and save that. So we call this destruct. And now if I actually go ahead and press play, I mean nothing's gonna happen, because although we have destruct, as you can see, we can't really define the logic here. The way you define the logic is, for example, we can head into pickup, under interfaces, right click, implement event, and if I go ahead and just print a string and I can type in destructing pickup, and if I go ahead and destroy it, so destroy actor and target will be self, and I'll do the same for the interaction actor. So implement this event, whoops, paste this in, and we can do destructing whatever this is, interaction actor. So now you should be able to see that both of these different implementations are actually called. So if I press play, you see our pickup is destroyed, and if I actually click on this side, our interaction actor is also destroyed. So this is how you basically use interfaces instead of casting. Basically what it's doing internally, even though this looks like we got rid of casting, is instead of casting to our interaction actor, it casts to the interface. Because interaction actor implements that interface, the cast is going to succeed and the function will be executed. The situation where the cast fails is automatically handled in the engine. Now, how do you do the same exact thing in C++, you may ask? It's pretty simple actually. You just use the concept of multiple inheritance in C++. So, tools, create a new C++ class, and over here what you have to do is select Unreal Interface, and we can just call this my interface for example and create the class. It should load up Visual Studio for you. So just reload that, and over here you should be able to see my interface.h and my interface.cpp. Basically this is where you would write the function definitions, and you can go ahead and define it in your various classes. So what you do is, for example, let's just have this function work for both the pickup and our whatever that was, interaction actor. So let's say we want this function to work for both of them. So let's go ahead and do that using an interface. We'll actually get rid of the C++ logic. So we'll get rid of that. And what we got to do is, first of all, since we are actually casting to the interface here, we can go ahead and include the header for that. So hash include over here. We can go, okay, we are including pickup already. So what we can go ahead and do is we can go ahead and include this interface in the pickup. So not after the generated, before the generated.h. And this is going to be my interface.h. And over here where you see public a actor, put in a comma and type in public I my interface. I is basically the prefix which is used for interfaces, just remember that. So my interface in the editor is going to correspond to I my interface in C++. So let's actually write our function. So let's call this void destruct maybe. And we can go ahead and add in our implementations. So we can right click first of all and make this one virtual. Right click, quick actions, create a definition for it. This is just going to be like your default implementation. So now let's say we wanted to implement this function in another class. It's really simple to do it. Now that we have a virtual function here, we can head into our pickup.h, and over here along with this we can type in virtual void, and I don't know what the function was, so I'll just copy this over. Do the same thing in the pickup. And since we are actually overriding a base class method, what we can do is we can use the keyword override. And now if I go ahead and right click, quick actions, create a definition, head in here, and now let's say we do the same thing. So let's say we do ukismet system library print string this, and let's just say destroyed pickup from C++. And we need to include Kismet of course, so let's just do that real quick. So let me just copy this over. So I'll just do this in the .h file. So now we can go ahead and actually destroy it. So we can say this destroy. or rather you can just call destroy. Alright, so we can go ahead and test this logic, but remember it's not going to work for our interaction actor because we again don't have another C++ class for it. So let's actually create that too. So new C++ class, actor, let's just call it, for example, I don't know, CPP underscore interaction actor. Okay, so we'll create the class. And what we can do is we can again implement this. So in order to implement the interface, so I'll just stop the editor there. So in order to implement the interface, we'll do the same thing what we did for pickup. So if you head into the header here, copy this over, head into your interaction actor, implement the interface, and again we need the header file. So what we can do is we can do hash include whatever this is. So we have my interface.h, and then we can go ahead and implement this event by using virtual void destruct, which was our function name, and we are overriding a base class method. So override, and now we can go ahead and create the definition for it. And over here we can go ahead and print the string again. We can do that by simply including Kismet again. So let me just copy it over. Oops, I copied that. So head back into your pickup where we had included it, copy that, paste that back in, and let's just copy over the code from our pickup. You can have different code as well. I'm just showing you guys as an example on how to use it. So we'll change what we print. So destroyed interaction actor from CPP, and this should work. Also just head back into your CPP file, your CPP character, and where we cast it to the pickup, what you basically do is instead of casting to the pickup, you cast to the interface, since we inherited the interface. So it's going to be my interface, and make sure you actually include the header file. I've already done that. So somewhere over here we have included pickup.h already, and pickup.h already implements the interface, and we have included the header, so we don't really need it. So we can cast to this interface, and instead of destroying and printing, what we can do is we can utilize this. So we can have this separately. So we'll just do auto temp equals, I'm doing uppercase temp because we've already used lowercase temp here, and temp is going to be valid because the cast has succeeded. So what we can do is we can call destruct from here. Alright, now we can go ahead and run a debugger. Now if I head back into my character, connect this up, hit play, and you should see that we say destroyed pickup from CPP, but the interaction actor doesn't work. That's because we haven't actually set up the parent class over here. So go ahead and change that to CPP underscore interaction actor, and we could rename this as well BP interaction actor. Alright, so if I go ahead and press play, the pickup works, and as you can see, destroyed interaction actor from CPP. So that's pretty much it. That's how you use interfaces. And later on, we will also be seeing more practical examples. This was probably a good one, but still we'll actually implement this in our actual game. Now let's look at another case where you want to call blueprint functions from C++. Now this almost seems impossible because your C++ classes aren't actually aware of what blueprint classes exist, but actually it is. It's really simple too. So what you do, you could use it in any actor, any object, even in the interface if you want, but I'll just show you guys in the character by just printing something. So the way you actually call blueprint from C++ is like this. So you just write a normal function. So let's just call this void test bp func, let's say. And now what you got to do is you have to use the u function macro, and You can make this blueprint callable or not, but the specifier that you need is called blueprint implementable event. So now you can have the function declaration over here. You can actually have parameters too. So we can test that if you want. So int x, let's say. So now if I actually run this, you won't actually get a compiler error because Unreal automatically generates the definition for you and you can define it in Blueprint. So if I open up my BP character and under functions, under overrideable, if you just have a look, you will have test BP func, and as you can see, I can actually implement this over here, and we also got our input parameter. So we can just go ahead and print a string. We can either call this through Blueprint or we could even call this through C++. Let me show you guys by calling it through C++. So I'll do it on begin play. So what was our function called again? Test BP func. And you would see that this is actually implemented. So let's type in 100 for example, and this will work. And in the meantime, now I would like to show you guys one more thing that you can do. I just wanted to show you guys that yes, you can actually do this. You can actually implement it in Blueprint. But there is a possibility that you have some C++ code, but then you also have some Blueprint code which you want to be executed. So in that case, what you would do is you would use another type known as Blueprint native event. So we'll just copy over this function and let's call this one test BP native func, and let's just have something else. For example, let's say we'll have a float, and for this actually what you need to do is you need to have another function called the implementation of this function. So that is going to be what you define in C++, and this is going to be your function name in Blueprint. So in order to explain what I mean, instead of implementable, type in native. Now if you compile this, you'll actually get an error. So what you're supposed to do is not create a definition. However, you are supposed to create an implementation for this. So the way you do it is you just copy over the signature, and instead of the same function name, you type in underscore implementation. Whoops, implementation. So what you can do now is for the implementation, you can go ahead and create the definition. Head into your definition and we can go ahead and print something. So let's say we go ahead and print, for example, let's just say C++ implementation called, and we can close that in. And for a Blueprint implementation, we can set that up in Blueprint, no issues. So that should be it. Now you can go ahead and actually compile this once again. So apologies, I just made a few typos over here. So let me just copy implement over here. So implementation, and do the same in the CPP file as well. So underscore implementation, and now you should have no problems. So if we head into our BP character, and we can go ahead and override both of them. So test BP func, we can go ahead and print it. Actually, this is our Blueprint implementation and we called it from C++. So okay, we'll just go ahead and print it. We are calling it from C++, so what should be expected is 100 is going to be printed. Even the native event, you can call it from C++. I'll just do it over here. So first of all, let me implement that in Blueprint. So implement that, go ahead and just print that. That shouldn't be that hard. And just grab in our begin play here. And instead of, okay, let's just spawn this. Let's keep all of this logic. And we can go ahead, and since we made it Blueprint callable, whatever this was, and we'll just take in some random value. Now if I compile and if I go ahead and press play, as you can see, we get 100 as well as our 42343 printed. Now your obvious question is, why didn't the C++ implementation get called? So if I actually go ahead and delete this, and if I were to press play,